For my senior project, I decided to build a guitar. But just building a standard guitar wasn't really good enough, so I decided to build a Gittler guitar. What the heck is a Gittler guitar? This is what it looks like. This is the basic design, and it was designed by a man named Allan Gittler in the 1970s. And he built his out of stainless steel, and this is just a little bit on minimalism. He was part of the minimalistic movement, so he wanted to basically strip everything away from a guitar that you could possibly strip away without taking away the actual instrument piece. So his design featured 31 frets, was made of stainless steel, 6 pickups, and the pickups are actually the tuners as well. So a guitar, oh, I don't know where my backpack is, never mind, I forgot a couple pieces. But anyways, I was going to show you what a tuner is. But the pickups in his design are also the tuners, which was a bit, I guess you could call it revolutionary. But, so how I started off, I wasn't going to recreate it exactly. I decided to sort of do my own spin-off. Basically, I located the patent, looked at the patent, and saw that each fret on the instrument was press fit into the neck. So it was a stainless steel neck with stainless steel rods press fit, which means that the tolerance between the hole and what you're putting into the hole is small, so that it press fits. You need to press it in for it to fit. Basically, what I needed to figure out was how am I going to do the fretboard. So it's a fretboard calculator. I located the patent, fretboard calculator. What material? Because the material, I'm using this mill, this is the mill that I used. It depends on the machinability of the material would matter, because if you're doing a press fit, it needs to be the right size hole. So the first person I thought of was Mr. Munn. So I went and talked to Mr. Munn, and he directed me to Whitney Henschke, who is present, awesome. And so yeah, big huge thank you, huge thank you. If it wasn't for him, this wouldn't be a thing. So I met with him and we discussed the project, and he was on board, which was awesome. And so he directed me towards a couple industrial supply companies, and from those supply companies I ordered the first materials. So we decided to do a test. So the test was going to be on 1-inch outer diameter black iron pipe, which I wish I had. It's actually in my backpack in the other room, but whatever. And do a test to determine what the right fret size was and what the right neck size was. So this is the first test. So again, determining fret size, neck diameter, and the fitment type. That was a big thing in the beginning, because we didn't know whether we were going to be able to attain a press fit. Because old mill, there's a thing called chatter, which is basically they mount that the bit wobbles while it's spinning. So that would affect the size of the hole, which means you can't press fit it. We're talking about thousands of inches here, like really, really small spacing. And again, material type. So this is the bit for the first test, which is a 3/16 diameter fret, 3/16 diameter mill, and the 1-inch copper pipe. So this was the result of that. And basically, what ended up happening was the drill rod, which is exact size rod, so that's exactly 0.188 thousandths, which is 3/16. The drill rod was fitting extremely loosely. So that could be due to a couple things, which I didn't realize at first. I just thought, oh, look, I have a bigger hole. It's not going to work. So bit speed played a huge part in this, because as we found out, one of the later tests, the higher the bit speed, the better the cut. But if you go too fast, you can burn the bit up. So what ended up happening was we changed the bit speed around. But anyways, these are at different depths. I believe 159 thousandths and 150 thousandths. Sorry, 139 thousandths and 150 thousandths, which means that the space above the neck, which is just going to be this pipe, to the top of the fret, would vary. So you can either have more or less. So the deeper, the less, the more. So from that test, we determined that, all right, we need different sizes. 3/16 is too small. It's not proportional to the 1-inch neck. And that we might want to try different materials for the frets, because drill rod is very exact. It's what you order is what you get. And we needed something oversized if we have an oversized hole. So if I'm drilling a 0.188 thousandths hole, I need to get, and it's drilling larger, I need a larger size. So from that test we determined we need another test. Here's the second test. Now for the second test, it was supposed to be part of a larger test. Basically, let's see if I can explain this right. Basically, let's see if I have a picture. I don't. Alright. I had 3 different options for neck size. So the neck size was either going to be 1 inch, 875 thousandths, which is between 3/4 inch and 1 inch, and 3/4 inch, which is 750 thousandths. And so to determine which would be best, the best combination of both fret size and neck size, we chose to use drill rod, oversized drill rod for the oversizement of the hole, and a roll pin, which is usually 10 thousandths oversized. So in this test, this was actually supposed to be a small portion of the test. The test was supposed to be much more intense. There was going to be the 3 neck sizes. There was going to be 6 cuts on each, all at the same depth, and that would, in theory, help me determine whether to get the right size, what size neck, what size fret, the fret material, the method of attachment. So this is actually welded, which we figured was going to be the best, but it actually turned out not to be, which was good. Yeah, so this is the first test, or sorry, the second test. The results of that first 3 cuts are at a depth of 185 thousandths, and we figured out that the deeper the cut, the better the fit. And so, concluding that, I had never used a mill before, which was it wasn't too steep of a learning curve, but it was definitely an issue that I had to deal with, which Whit helped out a lot and told me there's tolerances, you got to set, every time you mill something, you need to parallelize it, it's got to be straight, within 1,000th of an inch, which, I mean, your eye can't really do 1,000th of an inch, and all needs to be measured out, calipers, all kinds of stuff. Machinability of the material. The black iron pipe did not machine well. The black iron pipe was noisy as the bit was going through. It was crap. But it was a good test because we determined that from it. And next was bit speed, which I mentioned earlier. The faster the bit, the better the cut. We were running at a slower speed, which is not delivering us a good cut. So from that test, from this previous test, we determined that we need 1/4 inch frets and a 3/4 inch neck, which is what I ended up using, which is this is the 3/4 inch neck, and these are the 1/4 inch frets. So now to the bridge. So those are the frets. The frets were that was a hump that we came over, but bridge design was an issue as well, because with a guitar you have action, you have intonation, you have fret spacing as well, but action is the distance, the height of the strings over the frets, and if you have a crappy action, you're going to have a crappy playing guitar. So for the bridge, I needed to design something that would work, but it was not going to be based off of what Gittler did, because his design was his design, and I wanted to do something different. Basically, I never actually did it, because we ended up changing the design, but basically I was going to take a piece of, another smaller piece of tubing, and put it inside of the neck. So I guess it would be inside of this back piece here, and would be bolted to the neck, and then a plate welded on top of that, which the bridge would sit. So there is options here. I could either recreate a headstock of a guitar, which has tuners, which are little, it's like a little gear, ratioed head that turns around and tunes the guitar slowly. I could either do that, or I could buy something. So I was crunching, I was freaking out because I didn't know what I was going to do, and this came to mind. I thought it was going to work, but it wasn't set in stone. It wasn't really, it was possible, but I didn't really think it through as well as I should have. So what ended up happening was I bought a bridge. So these are some of the issues that I ran into with the bridge. Is the action, the bridge height, and the bridge mounting. And also, conversely to the bridge, you have the nut, which the nut is this piece here. And then another thing that I guess I should just mention is scale drawings. If you're trying to get an idea out to somebody, if I'm trying to explain something to somebody else, the best way to do that is a scale drawing, which Whit helped me with a great deal, because I'd try to explain something and I'd be talking, and he'd just, okay, I have no idea what you're talking about. So scale drawings was a huge help, and just, I guess I have pictures of them. But so here's the design for the bridge. And what ended up happening was I had to find a way to take this thing here, and make the top of these line up so that the action would be adjustable for these frets. Which I guess that's kind of hard to understand, but that was an issue, because originally this plate was going to be mounted centrally along that piece that was going to be inserted into this. But basically, that was a bit of a workaround. So I designed this plate, and the plate fits, the bridge bolts to the plate and welds to the pipe. And that's the design for the bridge. Next, we have the nut. So the design for the nut is just a 1/4-inch plate, just like the bridge. And the 1/4-inch plate, is this. That's the pickup. But yeah, the nut was a 1/4-inch plate, and then there was this angular cut that needed to be made to accommodate for the bridge. And now everything's done on this guitar to, hopefully, tolerance, mistakes, compounded error, to 1/1000th of an inch. Which is really important, because when you build a guitar, you need to have the right sound. It has to have the right intonation, it needs to be proper. If it's not proper, it's not a guitar. But basically, this was the design for the nut, and everything in this project, going through it, everything was a process. There wasn't one portion of it that was necessarily easy or obvious. There were issues with material constraints, as I mentioned. There were issues with how to attach things. Do I weld it? Do I press it? And I got really fortunate, or I got really lucky, because on the test, which I left in the other room, the test is basically what ended up happening was the drill rods and roll pin didn't fit. So none of it fit. It was all loose. So we were just like, okay, well, let's weld it. In milling it, we raised the bit speed, which caused the hole to be much more precise. And so those frets are press fit into the neck, which was a very important piece to this, because that's how Gittler did it originally. I didn't really want to weld it. It doesn't look nice. Discoloration. But yeah, basically that's what happened. And then for the spacing of the frets, which is spacing from both one fret to the next and from the nut to each fret was all online. So I just Googled fret position calculator, and it's at a 26-inch scale, which is the distance from the nut to from where the strings start to where the strings end, basically. And so these were all the numbers, which are a bunch of numbers. And basically what I had to do was set up a mill, create a jig that would hold a piece of pipe. So there's parallelization involved, which means everything has to be in a straight line. If it's not in a straight line, these frets would be cockeyed, everything would be screwed up. So putting this on the mill for the first time was definitely, it was a learning curve. It was interesting, because as I began to mill and get used to using the mill, things started to become a little bit easier, and you can start to foresee problems before they occur. So one of the things that we ran into was numbers, and Whit suggested cross-checking all of the numbers from the website, which proved to be beneficial, because one of the numbers, I think might have been my wrongdoing, were wrong. So this is the cross-check. Basically, you have the distance from the nut to each fret. The nut doesn't exist. I had a piece of, the piece of pipe was 3 feet long. This is only going to be, I believe it's only 22 inches long, the actual guitar itself. But where do you start? Where do you put that first cut? Because once you make a cut, you can't go back. It's metal. I mean, you might be able to fill it with weld, but basically, I had to figure out the distances. So, from the distance, from what I got from the website, which is the distance from the nut to each fret, and then the distance between frets, I had to subtract the distance from the first fret to the nut, because there is no nut. So starting on that first fret, all the numbers had to be adjusted, which is where the error comes in, because if I did bad math, or the spreadsheet messed up, or I entered a wrong number, they're all wrong. If you get one of them wrong, the next one's going to be wrong, the next one's going to be wrong, the next one's going to be wrong. So I completely screw myself, which actually happened. But it was actually, anyways. So I had to sort that out. So I milled out the neck. I think it took me a couple hours to mill the whole thing. But basically, the system was press it down. So the bit was brought down through the neck. And then there's wheels and there's lash on a mill. So lash, you could have like 5 degrees of lash, which means you can go like this with a knob for the mill, and nothing's going to happen, but your measurement's going to be off. So off measurement, especially with something like this, is not good. So you have to approach your cut a certain way. So approaching the first cut, I guess I'll go back to the mill. It might be easier to understand. So this table moves side to side, forward and back, and up and down. And that's how all these cuts were made. So in moving side to side, there's again, a degree of lash. So I had to approach whatever cut that I was making from the same direction, always. I can't go back. You can't go back and reset. I mean, you can go back and reset, but it's sketchy. You don't want to mess up your numbers. So yeah. Everything had a lash, and so I put the bit down, move the bit up, come out of it, and then move the table the right distance, which is to a 1/1000th of an inch. So one turn is, I believe, 1/10 of an inch. So if I was going to do, say, the distance from the first fret to the second fret was 1.4 inches, I'd have to do 14 turns, and then, say if it was 1.41, and then that little 1/1000th. Which was tedious. It was extremely tedious. And before, you're turning a dial. There's no, I can't see the measurement. I can't see 1/1000th of an inch. So every time I'd turn it, I'd come down and make sure it kissed the top of the neck where it would be, and take the calipers and measure exactly, and double check myself basically. So I'd check with this, double check with the calipers, to make sure that the cut was in the right spot. And then came this issue with only being able to make 11 cuts at once, and there's 22 frets. So what I ended up having to do was take the neck after I milled 11, so I'd start here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and stop there. What do? I have all these frets left. And if I move this, it's going to be off. It's going to be off both this way and this way. So what I ended up having to do was drop the bit into it and move the table while this stayed stationary. And I milled a flat on the far end of it so that I could put it, I wish I had a picture of it. I haven't had a phone for a little while, and anyways. But if I had, it would have been better. But basically I ended up having to move the table under this. And then recenter it, reparalyze it, and do this incredibly fine adjustment, basically based off my eye, because the flat was just a flat piece here, and I had to line up with another flat piece. It's just like looking down the sights of a gun or something like that. So in that lining up, the first time I messed up. There was error, and it wasn't completely parallelized. It wasn't completely flat. So the frets, I'd have a string of 11 frets that were nice and straight, and then the next ones were kinked like that, which doesn't work. You can't do that. So to fix that, I did the parallelization thing with a look down the sights, whatever. Let's see, where else am I? So that was milling the frets. And in milling the frets, I definitely learned a lot about milling itself. Plenty of oil, always. You can break bits, you can burn up bits. It's a very tedious procedure. Let's see, where else? Yeah, I guess I have time for questions now. This presentation itself wasn't really well planned out because of time constraints, but yeah, any questions?
How long did it take you?
Probably 20 something hours. I like lost track of time the whole time. Probably 30 hours.
In your opinion, does it play in tune?
No, does not yet. Not because of something that I did, but the bridge piece itself, these tuners here, these are threaded. So there's a block inside of this that holds the ball end of the string, and that block is threaded. These tuners thread into that. When I applied tension yesterday, I finished this yesterday, but when I applied the tension to the strings, it stripped the block entirely. So which means that the block is just free floating, it's not going to hold any tension. So that happened to this tuner, and this tuner, which is an issue. It's not my fault because I bought the bridge from Amazon actually, but yeah, so it does not play in tune yet. It will, not yet.
Can you like play it at all?
Yeah, sure. It's not going to be entirely in tune.
I want to hear you play.
It's hard because I can't really, first of all, I can't really hold it because it doesn't have a strap.
Can you play a scale?
A scale? Yeah, sure. Not in tune. It's just not, it works and it sounds fine. It's not entirely done. I have to shim up the nut because it's buzzing here, which again with guitars you have this thing called action, which is the height of the strings above the frets. And with that action, you have to, it's adjustable. So these are way up. These are not supposed to be this high. I just have to fiddle with it. It's fine tuning, but it plays. It sounds all right, you know. But it's not entirely playable yet.
We want to hear more Lucas.
More?
Yeah, play it.
Yeah. All right.
I heard what you got going.
What I got going? What's that? You tell me. I don't really. It's hard because I'd like to play something that actually sounds good, but I can't because it's not going to sound good. Like if I try to play a chord on this, that's just not nice.
For the untrained ears, it sounds good.
Oh.
Like me.
Oh.
Like mine.
Well, that's good.
My untrained ears.
It kind of sounds augmented. Anyways.
Maybe you can make up your own alternate tune.
Yeah, I was thinking about drop tuning it or something like that, but
Can you just play something on the low strings that are into it?
how could I play? I don't know. It's hard because you don't have the whole fretboard to use. I'm just trying to think of what else I could play. I could play another scale. But yeah, so that's how it sounds. It's gonna sound better than this. But yeah, that's it. Any other questions from anybody?
What makes this so different as far as like a standard guitar?
Well, basically, the idea that Allan Gittler had was he wanted to strip the guitar down. So,
as far as the design.
oh, as far as
But does it make music in a different way?
no, it's the same. It's the same thing. It's more player orientated. So rather than having a guitar that you're limited by the structural makeup, say an acoustic guitar needs to be made in a certain way, it has to have certain bracing. Basically, this is like this is all you need to play music on a guitar, at least on electric, specifically on electric guitar. But yeah, it's player orientated. It's not so much the music, but yeah. Anything else? Anybody?
Nice job.
Very nice job, but wait, how is this project sort of push you forward? Are you going to be pursuing this somehow in your future?
I actually want to start making instruments out of random stuff because it's been fun. It's just random things and I put it together and it works. So like I definitely want to start, I do want to pursue it, yeah. And I want to teach myself how to weld properly and do all the things properly so that while I'm in college, I might be able to make a little bit of money making weird guitars and presenting them to high school. I don't know. But, yeah. So yes, I do. Anybody else?
Oh, well, I was pointing at Mr. Connors, but
Oh,
I have one too. What kind of instrument would you do next? Would you do another guitar or something, like a different kind of
I
instrument?
kind of want to do a bass. Should be. I feel like that'd be, my idea for a bass would just be a huge pipe that's like that wide and then just put tuners all around it so it's like a circular bass so you can play it with your thumb and play it with the rest of your hand. But it has to stand, it has to have a stand, so you'd have to, but anyways.
Are you gonna sell it to Mr. Tennis for a lot of
I
money?
might.
Give it to you for free.
Yeah. Hey, I might
That's
ship
right.
it from Sydney, Australia, you know?
It sounds like you learned a lot about machining and working with metal. What did you learn about guitars?
They're very fine-tuned pieces of machinery, not even necessarily an instrument. But I've definitely learned that they're a lot more exact than basic precision. It's a matter of precision. If your fret is off, your note's off. If your nut is off, your note's off. If your bridge is off, your note's going to be off. There's so much room for error in this that, like, for example, if, per se, I was off by 2/1000ths of an inch on the second fret, that's only on the second fret. I've only made 2 holes. And I have 20 left. I have 20 left to mill. All of those are going to be 2/1000ths of an inch off, which then throws off, and then by the end of it, you know, by 20 times 2 is 40. Now you're like 40/1000ths of an inch off. The whole thing is going to be messed up if you mess one small thing up. So yeah. Everybody?
Yeah, how about failure? I mean, you were dealing with things where you failed in doing it, right?
Yeah.
And was that keeping you from moving forward because you got frustrated? Or how did you feel having to deal with that?
Failure was actually a huge part in keeping myself motivated because I'd get home from working at Witt's shop and I'd say, all right, well, I have this issue. This didn't work. How am I going to work around it? And so it really forced me to think sort of outside of the box. But it was definitely, it was good to fail. There wasn't like, oh, I failed. I never really considered it failure. I guess I kind of considered it as a way of moving forward because it determined, okay, well, this doesn't work. Trash it. Whatever. You know? So, failure.
So you got the bridge from Amazon, is that right?
Yeah.
So have you, I don't even know, can you build a bridge? Like, have you thought about, wouldn't it be, now do you think you might move forward and go, okay, Amazon sucks, I'm going to build my own bridge? Or?
Well, actually, that was my original thought. Actually, I wish I could grab the parts. Maybe Jack,
Are they here?
do you know the window over that way?
Yeah.
My backpacks. Do you mind grabbing that?
Yeah, what color is your backpack?
It's blue. You'll see it. Thanks, man. Anyways, so I'll show you. I was thinking about building a bridge originally, and so this Amazon thing came up. Originally, I was going to recreate the headstock of a guitar, except put a bridge on it instead of a nut. So I wish I had a picture or an actual guitar, but the tuners are not normally on that end of the guitar. The tuners are normally up here, at the end of the neck. So I definitely considered it, but it's really difficult. It would have been much more difficult than buying something. But that is something that I would like to pursue. Anybody
Could you
else?
actually put tuners at the,
Yeah, so the bridge came with the tuners.
could you put them at the other end of the, I can't remember the name of the without change, you probably have to add.
No, I don't, it might be the nut. The nut? I actually don't know if it's like the same style, Floyd Rose style, but it doesn't have tuners past it. Yeah. So the tuners are down here, these are the tuners, by the way. But yeah, any other questions?
So it seems like you ran out of time in some ways, not because you ran out of time, but because you started a project and you didn't really know how much time it was going to take. Knowing that now, what would you change in the future when you go and you embark on a new challenge that you don't really know how much time it was going to take? How do you, counteract that and get something done on time, even though this is a very impressive piece that you've done a lot of work, and that obviously shows, but you yourself are saying there's things that I could finish but aren't finished because of the time that you didn't know.
Right, so I guess one thing that I would definitely do differently is more research. I found the patent on Google Patents and printed it out, and what printed out was not the patent. It was just a whole bunch of lists of descriptions of the instrument, no actual sizes, no nothing. I could have, the first test of determining the fret size and the fret diameter, and the neck size and the neck diameter, they were in the patent, and I just didn't look hard enough, which is, it was a waste of time. It was a huge waste of time. But it was also good to go through the process of discovering, okay, well, this didn't work, so I need to devise a test to make sure that the next thing that I order online, which again, if you order this online, there's no picture of it. On McMaster-Carr, which was the company, there's no picture of this rod. And even if there was a picture, it's not tangible, you can't touch it. So, I ordered for the second test, I ordered a whole bunch of things, and I really only needed one of them, and it was completely pointless. So part of it is not having the tangible object in your hand, and the other part of it is research, definitely research. I would look into it more, and there wasn't any, but the other thing is that nobody, to my knowledge, has ever done this before. I mean, Allan Gittler, but no one's recreated his instrument before. So there wasn't much to go off of in that sense.
Just speaking of time, it seems like when you were talking about you had about 20 hours into it, it seems like, wasn't that more your machine time? That didn't include your thinking, your sketching, your problem solving, your working through all the stuff.
Yeah, 20 hours was, I think, I don't know, you like 20 hours, something like that?
I lost track.
Yeah, it's a lot of hours on a mill. And the funny part is that I say it's hours on a mill. I'm not actually really milling that much. There's only 22, 23, 24, 25 cuts that I had to make. 3 are not the fretboard. So it was really setup. Setup was the biggest part. If it's not parallelized, you're going to be screwed up. There's so many different margins for error that you have to calculate for and account for that I'm literally standing at a mill going like this, like, is that straight? Is this right? Is this right? And that was the 30 hours, because if you mess one up, you mess the rest of it up.
Do you know, or maybe Whit knows, is there, like if you're working in an industrial complex and creating all these machine parts for something like this, does the machinery actually exist now that like digitally would give you a measurement, or do you even know?
Well,
There must be like some,
there are,
because they make like all
I mean,
kinds of
he was basically using my mill, which
Right,
is,
exactly,
there are
so that's-
much more sophisticated versions of that
Right,
machine.
so that's what, yeah, so I kind of say that just because the emphasis of like how amazing it was that you did it on a relatively primitive, no offense. But
Yeah, that was part
beautiful,
of the,
absolutely gorgeous.
it was very old school.
Nice
But, yeah. Anything else?
There are lots of juniors and sophomores and freshmen in the room, and maybe you could say a little bit about senior project and what they might consider in choosing a project and how they might manage their time in the project.
Well, as for managing your time in the project, one thing I would definitely say is don't screw up. It's really, 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 really hard not to. It's hard enough to just be like, oh, I don't have to come, Tucker knows. I didn't have to come into school today. Like, oh, great. That whole time is supposed to be directed towards your project. And honestly, this presentation would be much more thorough if I had previously, I had 2 months to build this basically. If I had managed my time better in the beginning, and especially not so much towards the end it was just dead on, like every day. If I had managed my time better, it would have definitely, it would have benefited me. As for senior project goes, it is a wonderful opportunity to, one, meet new people, learn new things. I learned how to mill, I learned how to machine, I learned how to measure to the thousandth. There's countless different skills that I've learned just from building a guitar, and it's building a guitar. It's not this huge crazy undertaking, but definitely choose something that is slightly out of your comfort zone. I did not think that this was going to be this difficult at all. At first I was like, I talked to Mr. Connors and I was like, hey, check this out, like I want to build this guitar. And he was like, oh, you're nuts, like this is not going to happen.
But I also encouraged you to do it anyway.
So it was two-sided there. But it's definitely a great experience. It's a great way to pursue something you're interested in. I mean, people are doing things about choreography and art, and if you want to go around and take pictures of stuff and learn about culture, and you can learn about whatever you want. That's the best part about it. So, yeah. Anybody else? No?
Congratulations.